Well, welcome. We're just past time, so I think we're going to get going. Appreciate you being here. I know it's a beautiful sunny day at the end of the conference, so I think attendance is a little light on these sessions, but hopefully you have a little bit more room to absorb some more information. So I'm Caleb Baker. I'll be presenting on user identity and authentication for desktop and phone applications. I work in the federated identity team. Particularly, I'm a program manager for ACS, Access Control Services, which I'll talk about a little bit more farther on. Just to level set, to make sure this is the appropriate audience, this is largely going to be a developer-focused talk. So I know, a large percentage of the tech ed crowd is IT focused. So if this isn't a talk for you, that's fine. I'd rather you go somewhere that you can get the appropriate information. And then also, I do assume some background in federated identity. I'll explain some concepts, and particularly with the smaller group here, I can cater it some. But for the most part, I'd assume some understanding of Windows Communication Foundation, WCF. All right, and with those caveats, I'll get going. So in this talk, I'm going to be talking about federated identity and go through some models that you can use for Windows Presentation Foundation, Silverlight, and Windows Phone 7 to write rich interactive applications and use federated identity to have the identity cross trust boundaries, and I'll get more into that later. And then also, as going through it, I'll identify some of the design decisions that you might have to think about, which is really independent of technology that you're using, but common patterns that I've seen as I've gone through and worked with different customers. Just to start out with a little level set. So to me, rich client application is an application running on the user's desktop that calls a web service. So very simple model of it. Been around for a long time, line of business applications, simple data-driven apps that call back, can present this information to the user in a richer way. And the authentication model here isn't particularly sophisticated. You can log on to the Windows desktop, use Windows Auth from Active Directory, and then Windows Authentication to connect to the service. But there's certain trends that are occurring, and the cloud being one of them. The trend, I know these are somewhat not very surprising, but the cloud presents a few wrinkles. So of course, you can't use that model where you have Windows Authentication going from the desktop out to the service in the sky. Instead, you can still use Windows Auth on your local Active Directory account, but you want to get single sign-on so your users don't need an additional account to log on to that service. So we'll look at how you can do that in a rich client application. Naturally, when you think apps, phone, again, it's unnecessary to stress the importance here that the marketplace and user demand is really driving an explosion of applications. And it makes the problem more difficult, because at this point, you can't rely on the Windows authentication for the user's initial auth, as well as you can't rely on it to authenticate to the service in the cloud. Another trend is coffee shops. Well, just kidding. Social. This is so social networking, and users have their identities spread out across different identity providers in the consumerization of identity. And maybe you want to have someone connect from Facebook. Probably not an employee, but it could be a contractor whose account you don't want to manage, or just a customer. And then you can outsource all of that account management to whoever that identity provider is. You don't have to handle the password reset calls or provisioning the accounts. Now, to tackle these problems, we're going to use some very standard tools for federated identity. The first one being claims. And just so I can get the temperature of the room a little bit, who's here familiar with claims? Okay, so it looks like maybe 75%. The quick overview is claims really aren't all that complicated. It's a statement about a user asserted by an authority. So it could be a username, for example, asserted by that identity provider, and it's cryptographically signed in some way so that you can validate it. It also provides a much richer model than just like what's available in Windows Authentication. Since you can bind arbitrary information, you can do roles, location information, age ranges, hair color, really whatever your app needs. And that gives that application that might be up in the cloud information about the user without having to have some way to call back and get that from the Active Directory. Claims, we package up in tokens, so I'll talk a lot about those. That's what flow through the system. The security token service is the service that produces the tokens, and the relying party is an application that uses those tokens. And specifically, the products that I'll be using is Windows Identity Foundation, or WIF. I have a tendency to fall back and say WIF, which I'll try and avoid. I think it's because I went to the University of Washington, what was UW. So if you hear WIF or WIF, that's what I mean. Also, Active Directory Federation Server, which is the STS that you can attach onto Active Directory to enable a lot of these scenarios. And also, as I said, I work on the Windows Azure App Fabric Access Control Service, which is a mouthful, so we just call it ACS. And this is like ADFS in that it is a security token service, but it's hosted in the cloud, and it also is going to enable some more of these scenarios around different consumer identities. All right, so now I'm just going to take people through a real basic flow to see how this would work. And you have an application, and it would need to make a call out to, in this case, ADFS. And we'll be using, for the first bit of this flow, a WS Trust protocol, which is a standardized protocol. It's supported by other products. Of course, I'll be showing it with ADFS and Windows Identity Foundation. But there's other vendors that also support these protocols. Once the user is authenticated, a SAML token is returned. And the SAML token is really the most common token type that's used throughout the industry. It's just an XML data structure that contains the assertions and claims about the user with a cryptographic signature. So then you can relay that token to the service that you're authenticating to. As long as it has the public certificate that was used to sign that token, it's able to validate it, and the user's gained access. All right, so let's jump into a demo. And we're going to show just doing kind of the most basic scenario with Windows presentation, with WPF. And first, I want to show you the service that I'm calling. It's just going to return some data. The actual contents isn't all that important. I have it modeled right now after a customer scenario, which was they had patient information that was outsourced to an ISV, and doctors could access it to get different information. So here I have my very simple patient database where I map a doctor to a patient name. And then my authorization check I'm able to do by using Windows Identity Foundation. Because when that token arrives at the relying party, it hydrates into a claims identity, which is just derives from the iPrincipal iIdentity that any of you that work with ASP.NET are familiar with. And then you can iterate through that claim set and make decisions. So in this case, I'm using a link statement, and I'm finding any cases where there's a doctor. And even more than just a doctor, I can also verify that it's a doctor from a particular security token service. So I'm checking the issuer name here. So if I had, like, for instance, two doctors, Frank M at, of course, it has to be Contoso Healthcare and Fabricam Healthcare, that if the issuer was Contoso, that would map to a unique identity. And then once I do that search, I can return the doctor those patient sets. And you can see really the flexibility here, that you could do different queries that maybe it was on hospital. They could see the entire patient list, or even region or location, whatever information was passed in the token. So I'll switch back over to my WPF application. And I've created this app just using the standard WCF tools, where I can use svcutil and point it to the service, and it generates a client-side proxy for me that I can call into. And that's what I'm showing here, is that I have this service proxy that knows how to speak WS security and the protocol in order to connect to the service that's going to return the patient information. And then I can pass it username and password from my UI, which behind the scenes, what it's really going to do here is it gets this information, it sends it to the security token service, and then it chains. And if there's more than one security token service, it would chain through them all and return the token to the relying party. And then I make my call, and the application just works. So this is kind of the vanilla experience, I think. So my beautiful UI design. So it'll go out and make a call to the security token service, which sometimes takes a little while to start up. I should caveat and say that, so I'm not actually using ADFS just because of the size of my machine. I've written a security token service using Windows Identity Foundation that use the same bindings and everything to simulate it. All right, so as you can see, the data was retrieved and I was able to authenticate. I can sign out, log in as a different doctor. Conveniently, they all share the same password. And I get a different patient list back. So in this case, just real basic federation is pretty easy to work in. And we're going to go now into some more detailed scenarios. So I'll switch back. OK, so this is an overview of the flow that we were looking at. And yeah. To use like a Windows authentication to log on? Right. Yeah, so then in that case, it would default to using Windows integrated authentication, and you wouldn't have to set the credential. So it's actually less code. It pretty much works the same, and it would just go out and retrieve and get the token. So for the username and password case, I'm using this specific WCF binding because it works across different app models. I'm sure that's too small for you to see. So a blown up version. So it's standard WS2000 HTTP binding. And I'm going to use a mixed mode binding, which means the client can authenticate the server to make sure it's talking to the right STS, just using SSL. And the message credential part of it is that the client is going to authenticate with a credential that's in the message body. In this case, credential type is username and password. For ADFS, the endpoints that you want to use, because you don't have to go and do that manual configuration, but you do have to select the correct endpoints to target. And all the ADFS endpoints are templated. So in this case, plug in your server name here, and then go to the correct endpoint. You want to make sure the endpoint is enabled. In the ADFS UI, there's an endpoints tab, and there's over a couple dozen endpoints, so you could go in and check these. Just like we had to have a binding on the STS side, we also need to have a binding on the server side, of course. So in this case, it's a little more complicated since it's a federated binding. And in this case, I'm doing custom binding because I want to be able to control with higher fidelity what's going to happen, and also make sure that this binding can work across the other apps we'll be working with later on in the presentation. So this is an issue token binding in this case, which means this service requires a token, a SAML token, to authenticate. There's this long string, which represents the security protocols that are being used. I won't bother to elaborate too much on that, but it's important to get it right. And then there's also specifying the endpoint that the token is going to be retrieved from. So just quick review. So far, we have a WPF application working with ADFS, calling a service outside of the security boundary. Now, a really common problem that people have is, how do you get the user identity into the application? The model's a bit different than when you're writing a Windows app, where you can just do current.user and get the user's name and do something. Because in this case, the user's really authenticated out to that service. So that's where you can check the user's identity. The app is just running however the user happens to be logged on at the time. And there's some pretty reasonable patterns that people want to follow here. They want to be able to personalize the app, give a welcome message, say who's signed in. Or you can also do some customization based on task. If you have an administrator and something richer that you can determine from those claim values about what the user can do, you don't want to show them a bunch of options that aren't going to apply to them. There's a couple high-level patterns that you can use to do this. And the first question really is, where do you want to get that information from? Sometimes the service you're calling has a better idea who that user is operating in that context. It might just be they've used the token to authenticate to a profile, and you're able to get more richer information. Or it could be that the identity provider, particularly in a line of business application case, understands that user's identity and what it's going to be across the range of applications that are being accessed. The advantage to that model is that if you can take that from the identity provider, you can remove one hop because you're no longer authenticating and then querying the service for who that user is. So I'm going to show an example of doing that with WS Trust because there's some protocol support for this exact pattern. So instead of going through the full flow, I'll just add this one little bit, which is in the response. You can also request to get a display token, which is part of the WS Trust protocol. And this allows you to have a token that's specifically meant for the client application to look into and display to the user. Adding this to the application is the next thing I'm going to show. And it's a bit more of a complicated scenario. Really, this is where some of the power of Windows Identity Foundation comes in handy. Because right now, as you can see, as I've shown before, you don't really have a whole lot of control over the message that's being sent. Everything's just seamlessly happening behind the scenes. So I'm going to make some changes. The first thing I'm going to do is I'm going to switch over to using the interface that was generated by SVC util instead of the class itself, because that way I can instantiate the class using a channel factory. I need to go back and get my code snippet. So I'll remove this code that I was using to authenticate before and add in the code that I'm going to call into in order to request the security token. Now this just really points to a function that I've written because I didn't want to have to copy and paste everything across, but it also gives you an idea of what all the main parameters are. You need to specify the security token endpoint that you're going to be calling, and also the service that that token is going to be requested for. The importance of that is when you make the request for a token, you want that token minted specifically for that service so that when you go and authenticate, that service can't turn around and use it as at a different service and impersonate the user. So that's a key bit of information. And then, of course, the username and password in order to authenticate. So I'll go into the function to give a bit better of an idea what's being done here. And I'm going to be using the WS Trust channel factory from Windows Identity Foundation and setting up the binding. This is the same binding that I showed previously. Setting the username and password on the credentials. And this is the real key difference from what we've done before, is that I can modify this RST, the request security token, which is an object that represents a WS Trust token request. And I can say I want a display token. So now that's going to be returned to me in the message response. So now I'll go back up to my app code. And I need to add the code now that's going to read that display token and display it to the user. I think I dropped that in the wrong spot. Do that one more time. And what this is going to do is it's just going to get a hold of the response, which is RSTR, request security token response. And then off of the request security token response, it can access the requested display token and all the display claims. So I just search through, find the name, assign that to a string, and then I'm going to put that in the welcome message. Hit F5 and run the same application that we looked at before. Log on. Goes out and retrieves the token. And really, it's up in this upper right is the difference that it's able to say, this is Frank. It could get that claim from the display token set. So that's a very seamless and easy way to get the information instead of going and like producing a new service using some other protocol. All right, now back to the deck. And this is my nice illustration of the SAML token, the display token getting dropped off, smashing into Frank's desktop, and welcome, Frank. So it all works. One word of warning here. I've seen it several times that people also use these claims to perform authorization checks on the service side. You don't want to assume that, by disabling some button on the client, that you're disabling that option for the user on the service. You want to have a separate authorization check. So for instance, if a task requires admin rights, it's the service that needs to check it. Otherwise, there's ways that can work around it, right? If someone writes a malicious application that can still request a token and access that service. And I'm sure none of you would do that. It seems fairly obvious, but it is something I have seen done, so I wanted to make sure to call that out. All right, so next we're going to talk about doing this in Silverlight. And some of the drivers I've seen for customers doing this is really ease of deployment of the application instead of having to do downloads and have it on all of the, for all the users. And it also gives you a broader reach across operating systems. So I'll go into that, and I should caveat this by saying, so this is using code that's in the identity training kit, and I have a link to this at the end of the slide. And there's an implementation of WS Trust in there that you can use that works with these endpoints that I've described on ADFS and also on the service. Now, part of the real power here that is going through and switching between these different application types is the model looks extremely the same. Once you learn the concepts for one, you can apply it to the others. In this case, in the Silverlight application, I'm doing the same thing. Thank you. I've set up the WS Trust client, and I'm passing in the same binding information in order to authenticate, the security token endpoint, and the user credentials. I can modify the RST in the same way as before, because I want to have the username come back for me. And then in Silverlight, everything's event-based, so in the event callback is where I actually do the operations to set the username and to call into the service. So it's really the same concepts. And I can just go in, and using this Silverlight application, without making any changes to the service that I'm calling, or the security token service, just sign in and have everything work. All right, so we've covered Silverlight and WPF cases. And now to talk about Windows Phone 7. For Windows Phone 7, it was a fairly straightforward port. There's one caveat there, which I'll explain on how to port the code over from the Silverlight training kit to run on Windows Phone 7. But of course, since all the applications in Windows Phone 7 are also Silverlight, it worked out pretty well. So I can just jump right back into a demo. And in this case, naturally I'm going to be showing the same service just to kind of emphasize the point that this is pretty straightforward to apply the concepts across app styles. Things are split up because in the Windows Phone model you have different pages for everything, which makes it pretty nice. So I'm using WS Trust Client again and setting the credentials, yada yada, all the stuff that you've seen before. And then when I come in here, I can pass the token and authenticate to the service. Start that up. Okay, so I can go in here and as Frank again, sign on. And as you'd expect, the token comes back. And I can also sign out, which clears out that token. So this gives you a lot of flexibility between switching with different application styles while reusing those same services. All right, so we have our three apps working. Okay, so this is the caveat. This is the slide that I don't like showing. This is, like I said, everything was pretty easy to port over. There was one big glitch that I had, which is in the Silverlight XML libraries, there's a bug that it doesn't disable formatting. So when you get these XML messages on the wire, the security messages, it formats them for you. So they look nice and pretty. Right? The problem with that is that then once it's formatted and you send it on the wire to call onto the service, it fails the signature validation. So your auth request fails. So this is, I won't dig into this at all, but this is my sample function that you can use that removes the formatting and then the call works. Now, for the phone, usability and security are kind of running head to head. You have this smaller device that's hard for users to type their passwords into, but at the same time, you have something that's easier for them to lose and potentially easier to be compromised. So there's always discussions about, like, do you cache the username and password? How long can you do that for? And really, where I've seen a lot of people land, and one way to consider this is you can cache that token. If you up the token's lifetime, you can cache that for a period of time. So you just have the user authenticate, use that username and password, request a token, save it to isolated storage, and then reuse that. It limits your risk, since if someone gains access to that token, for one, it's just for a limited amount of time, whichever, obviously you don't want them to be able to log on, but it's still a limited amount of time, and then they'll lose access. The other thing that's nice, another aspect that's really nice about it, is that since it's scoped for a particular service, whatever token is going to be used for, that's the only service. Like if someone steals the username and password, then they've gained access to everything. So it's limited your risk quite a bit there. One of the cons with the approach is users understand how to revoke their password. They go and change it. They lost their phone, they can quickly disable it. In this case, going and changing your password doesn't revoke the token. So there is that additional risk that the token will be good for whatever lifetime it was issued for. A trick that you can use in ADFS to then up that token lifetime, this is slightly hidden, is you can go into the PowerShell command lines, and per relying party that you're sending tokens to, you can say, like, okay, I know this is going to be a phone application. I want to up the lifetime to 10 hours a day, and it'll only affect that application. And this is the PowerShell command line that you'd want to use for that. All right, so now to talk about multiple identity providers, moving a little bit outside of the line of business application scenario. In this case, if say you want to write a phone application and access a service using a variety of identity providers, you might still want to use ADFS, but you also Facebook, LiveID, Yahoo, Google. Managing all of that in your service is a bit cumbersome. So we have the access control service, which is another security token service, and your service can trust tokens from it. So then what happens is one of these identity providers issues a token, so one of the green tokens, and then that goes straight to ACS. At ACS, you can manage which identity providers you trust and specify different authorization policies. If it passes the check there, so this is really the gate to your application, so you don't need to have this logic in your app. If it passes that check, it'll issue a token for your application, and then the user can be authenticated. For this model, instead of doing active calls, so we tend to call like the WS Trust calls, where it's all active web service calls, do a passive call, which is done through the web browser redirects for the initial stages of the authentication. And the main reasons here are to support those variety of identity providers, since they have passive protocol flows. And then also, there is something nice about showing that page that can be controlled by the identity provider and branded appropriately. For some scenarios, that's it fits a lot better. It's also a lot lightweighter to implement. If you're going cross-platform and you wanted to implement the authentication flow, WS Trust, SOAP can be a bit cumbersome. In this case, I'm also switching token formats. So I wanted to add this slide because this is a lesser-known token format, which is a simple web token, or SWAT token, SWT. And it's basically just like a query string. It has name-value pairs and an HMAC signature at the end. So the application just has to implement simple symmetric key signing validation in order to authenticate ACS. So we can walk through the flow. And the first part of the flow is actually interesting. Before doing the request for the security token, it can call ACS and do a get on an IDP list that's configured for that relying party. What that returns is a simple JSON structure that has a display name for the identity provider, and then also the URL that'll be used to redirect and access the token. So in the app, what you can do is make this call and then show to the user which identity providers are configured. When they click on one is when the redirect occurs. And this is nice because then, after you've deployed your application, you can go back to ACS and you can add or remove different identity providers, and it's just going to show up automatically inside the application when it starts up. So then once the user clicks on that link, it goes and makes a request to the STS, gets a token back, and then that token is negotiated, it's posted back through the web browser, and is sent to ACS. Now, normally in one of these flows, you would then have it posted back to the service, but what ACS will do is it'll host it inside a page at ACS that calls in JavaScript the notify function. And the notify function can be attached to inside Silverlight, inside the phone Silverlight application, so that there's an event handler. And that way, your application just kind of sits there and it waits, and as soon as there's a security token available, it gets popped up into the app, and then it switches over fully into app logic. And in this case, I'm then going to make an OAuth call to the relying party. The format here is really simple. It's just taking that token. It's the reason I used the SWAT token, is to have a smaller format, and shoving it inside the authorization header with the keyword. So it's really simple to implement on the service side as well. All right, so now I'll go through and I'll show this in action. First, I'll give a little bit of a look at the code in my exercise application. So just setting this up from the control, which is also in the identity training kit, or you can download it from the ACS Codeplex site. Again, I have those links at the end of the slide. So you can download this control, and then inside your app, you just need to specify a few bits of information. There's a realm, and this realm is the identifier for the relying party that's going to be called. This is what's going to get printed inside of the token so that it can't be replayed across to other services. Also, you specify your service namespace. So when you go to ACS, you register for a tenant, and that security tenant is where you're going to make all your configuration. So by adding this on here, it knows which tenant to go to. And that's where it's first going to go and make that JSON web call, which I can show. So I'll back out of this app, switch over. Wrong one. All right, so I have my exercises application. So when I clicked on there, I saw the progress bar go across. That was retrieving the JSON feed that then sucked down this list of identity providers. When I click on one, the app waits, and this is all done in the control, until it sees that a page navigation is completed, and then it shows the sign-in page. So in this case, I'm logging on using Google. Always nice having the show your password feature. All right, so then it goes out, it gets the token from Google. That's been posted across to ACS. ACS makes that event handling call. And as you can see, it's really, really pretty snappy, since it just makes the JavaScript call and immediately the application detects it. And then it can go out and call onto the service and get my list of exercises. If I sign out and then log on with a different identity provider, like LiveID, which I've previously signed on with and marked to save my credentials, and then in that case, it's just very simple, because I can click onto it. Everything's seamless. Since it never stopped at a page navigate, it just gets the token, posts it to ACS, and I'm logged on with a different account. All right, so we've gone through that. And then, natural question is, how hard is this model to implement on different platforms? So I've played around with Android a bit and done the same thing. It's pretty easy to do. There's a concept of a JavaScript interface that you can register. So then you just register a JavaScript interface, and that detects that same notify call. And you're able to pass the token back into the application, and everything just works the same. I haven't done iPhone yet. I'm looking for time to do that, but I've done a little bit of reading, and it looks like it should be fairly straightforward to do as well. Okay, so that some considerations that you might want to think about when you're using this model, though, is there tends to be an assumption that, okay, just because you're entering these username and password in a different web browser control, that it's outside of the application, that it's more secure in some way. But really, that web browser control is still hosted in the app. That app has full access to the DOM. And even if it didn't, it would be pretty trivial for an application to spoof that experience and it not really be a web page. So it's still key that there's some way that the user has trusted, whether it's because it's from a marketplace and it has good reputation or it's a line of business app. But this doesn't provide very strong security from a phishing attack. There's not really a consistent model for sign out. In the WS Trust case, since it's all active and you have control of the token, sign out basically just means throwing away the token. For this case, since there's all the different identity providers and they implement different protocols, there's no standard way to do sign out across them. So like in the Live ID case, we're doing sign on using the WS Federation protocol. So you can send a sign out to them and log out. But Google doesn't really have an option because it's just not a flow that they're supporting in here. So it's something to keep in mind. And then you also have the requirement, to make it look more seamless, that the identity provider should support a mobile-specific page, which is becoming more and more common. But if they don't, and you just go to like a standard logon page, you get like the big blow up, and you have to span around and check on it. All right. Well, that went faster than I was expecting, but so coming to the end here, so I think I've gone through the cases and some of the main design decisions there. The resources that you want to look at are the ACS Codeplex project, the Identity Training Kit, and then also the Windows Azure Toolkit for Windows Phone, which follows that same model with the web browser control. General track resources. So yeah, so I'm just going to go into Q&A if people have questions. Yeah. That's right. Throughout all of those different flows, I never went back and modified the service side at all. It gets the security token. As far as it can tell, it's the same protocol. Nothing's changed. That's just a standard part. So the real important part there is to use the correct binding. So it's very standard usage of WCF, but WCF, like in that configuration sample that I showed with all the bindings, there's hundreds of different combinations that you can do. So the trick is always like figuring out those exact settings. But as long as you take that and put it in, it's very straightforward. Yeah. So you can definitely encrypt the token if you want to. How this model works is that the token is just passed as an opaque blob through the client application. So you can go ahead and you can enable encryption on the ACS side, pass it through the client application, and have the service verify it. And there's no added support that's needed on the client. So on the service side, so you'd want to make sure that has the public certificate. So how you would set that up is you'd have a PFX file that has the private and public certificate on the service side. And then on the ACS side, you would just give it the public certificate. So it can encrypt the token, send it through the client, And then once the service receives the token, it can do the decryption. Sorry, say that one more time. For forms? So in the case of forms, like the web browser flow, you could do that if you had like a security token service using Windows Forms. You could easily write a security token service using Windows Identity Foundation with forms as the auth method, and then issue the token that'll go to ACS and sign on to the app. Yeah. Because the question is that when the service gets the username and password, that it only requests the token once and then can use it multiple times? Right. Right. So yeah, so you set the security binding on the STS about the required authentication to sign into the STS. And then there's also the binding that you set on the service. When you go and you authenticate to the service, well, first normally what happens is you go and you check the service and it gives you like metadata that describes what it requires for authentication. Then you would know to go to, or this is how WCF does it. It knows to go to the STS. It can check that binding and see what the authentication requirements are. And you can swap that out. Like the service doesn't need to know how that leaf node credential occurred. Like, you could switch between Windows or username and password, and it wouldn't affect the service side. Yeah. It would be hard to use it in the phone, yeah. Something I'd love to see, but yeah, so at least in Windows Phone 7, there's not currently a way to provision user certificates for doing that authentication. Be nice, though. Any other questions? Yeah, so the tokens do have lifetimes that are built into them. In the WS Trust case, what you can do is, so the token is returned with inside a larger message body. So you get back the request security token response, and that has token lifetimes in it as well. So you can look at those and you can see if if you're doing some caching, you can set a cache lifetime. That's also true for the ACS case. It's returning the token inside a request security token response. It's JSON serialized. The control that's there, and I could, well, inside part of this code for the phone, what it does is it has a call that's just simply a, is there a valid security token? So here, so it contains valid request security token response. So this library understands that lifetime, and so if there's not a token there, it's going to go down and send the user to the logon page, or if the token's expired, it'll send them over. Particularly in this example, since it's saving the token to isolated storage, that was an important feature to have, since it could be, the user closes the application, comes back a couple hours later, and starts it up again. You could, yeah. So you'd be able to clear out the isolated storage if that's the security you wanted, definitely. All right. Any other questions? Okay, then I'll finish up, and thanks again for coming. Hope you enjoy the rest of your day and the after party. Have a great time.